Imagine for a second that you're walking up to this massive, frankly terrifying piece of heavy machinery.
Right. Something just totally intimidating.
Yeah, exactly. Like we're talking something 3 stories tall, it's covered in grease, radiating heat, smelling of diesel and dust. And you have never seen this specific machine before in your life.
You wouldn't even know where to start.
Right. You have no idea what it's called. You don't know who manufactured it. And you certainly, don't know how to operate it.
Yeah.
But the second you stand in front of it, you instantly know exactly how to safely dismantle it. You know how to diagnose what's like rattling inside the casing and how to run it.
Which is crazy to think about.
It is. And you aren't just guessing either. You know it with the precise, ingrained confidence of someone who has worked on that exact machine for 30 years.
I mean, it sounds like a scene from a science fiction movie, right? Like where someone just downloads a helicopter pilot program directly into their brain.
That is the exact mental image I had. But the thing is, it's not science fiction. It is the very real, very pressing mission of a new technology we are looking at today.
Yeah, and it's a huge shift.
It really is. So we're examining a release from EON AI Ventures detailing their new platform. It's called EON Universal for mining. And the mission of this deep dive is to explore how safety-critical industries are scrambling to capture the vanishing expertise of retiring workers.
Right, because that knowledge is just walking out the door.
Exactly. And they're trying to do this not by forcing new humans to memorize more manuals, but by teaching AI to actually understand the physics of physical labor. So, okay, let's unpack this, because this isn't just a dry corporate press release about some new app.
No, not at all.
It is a window into this fundamental shift in how human beings and machines are going to collaborate, like in the dirt, in the mud, and in the real world.
Yeah, and to really understand the technology, we have to start with the crisis that forced it into existence in the first place. The industry calls it the expertise cliff.
The expertise cliff. Okay, explain that.
So, across open pit mines, underground operations, heavy processing plants, you have these people who hold 30 years of hard-won judgment. And they're just retiring en masse. We are losing the veterans.
Wow, yeah, that's a massive brain drain.
It is. And these mining sites are, well, they're often highly remote operations. They require these fly-in, fly-out commitments that keep workers away from their families for weeks at a time.
Which is a tough sell for a lot of people.
Exactly. So because of those demanding conditions, replacing those veterans is proving incredibly difficult. It makes that stored human knowledge incredibly scarce.
Meaning the crews coming in to replace them are basically, by definition, totally green. They're new to the environment, new to the equipment, and crucially, new to the danger.
Right. The danger is the big variable here.
Yeah, I mean, if a green employee at a software startup pushes bad code, you get a bug report. You roll back the server, you buy them a coffee, and you fix it.
No harm, no foul.
Exactly. But in mining, if a green worker makes a mistake, it is an immediate safety hazard. In this domain, being wrong can mean catastrophic equipment failure, millions of dollars in downtime, or, loss of life.
Yeah, the stakes are just incredibly high.
You simply cannot afford to have people guessing when they're dealing with massive kinetic energy and high-pressure hydraulics.
No, you can't. And the historical approach to this problem has been to throw just absolute fortunes at training content, specifically these massive, bespoke physical simulators.
Oh, right. The multi-million-dollar virtual setups.
Yeah. A company will spend millions of dollars perfectly recreating a specific plant, let's call it Facility A, in a virtual or even physical environment. They build a perfect digital twin of that one site.
But the sources note that these bespoke simulators have a massive structural flaw, right? Because they are modeled by hand for one specific geographic location.
Exactly.
So the moment Facility A upgrades a pump or, swaps out a conveyor belt motor or changes its safety routing, that multi-million-dollar simulator is instantly obsolete.
Yep, it's just out of date immediately.
It feels kind of like trying to learn a foreign language by memorizing every single possible sentence you might ever need to say in your entire life. It's an endless, hopeless task.
That's a really good way to put it.
Right. Because if I want to speak French, I don't just memorize where is the train station and I would like a coffee and pray. I never need to ask where is the coffee on the train.
Right, you'd be totally stuck.
I learn the vocabulary, I learn the grammar rules, and then I build the unique sentences I need in the moment. So why on earth did heavy industry keep pouring money into something so rigid for so long?
Well, honestly, it was software limitations. For a long time, the software simply couldn't handle the the grammar of the physical world. What you were describing, memorizing every sentence, that's what computer scientists call enumeration.
Enumeration, got it.
Yeah. The industry treated physical work as this infinite list of specific sites and specific plant configurations that had to be painstakingly mapped, memorized, and modeled by human developers.
It just sounds exhausting.
It is. And enumeration fails because it scales endlessly with the number of mines and the number of changes at those mines. It is a recurring cost that never, ever ends.
Right.
So EON Universal represents a foundational architectural shift from enumeration to what they call composition.
Okay, composition. Let's break the mechanics of that down. How does the software platform shift from memorizing a map to actually understanding the grammar?
Right. So if enumeration is memorizing the sentences, composition is learning the vocabulary to build any sentence.
Hmm.
The core insight EON had is that a mine is not a monolith.
Okay.
It isn't one giant, unique living organism. A pit, a processing plant, a mobile fleet, they are all assembled from a finite library of known equipment.
Things like shovels, haul trucks, crushers, that kind of stuff.
Exactly. Mills, conveyors, pumps. They might be arranged differently from one site to the next. Maybe they're painted different colors or bought from different vendors, but the underlying mechanical components are the same. Yeah, so EON Universal's breakthrough is to build a model of that vocabulary rather than modeling the specific geographic locations. You don't model every mine. You model the equipment every mine is built from.
I want to pause and talk about the math of that because this is where I genuinely had to do a double take while reading the data. EON calls this the bounded library,
Yes.
and they break it down into tiers. Tier 1 covers the core fleet and the plant equipment that a crew actually touches on a daily basis. The claim in the press release is that just about 50 equipment classes cover 80% or more of real field interactions.
I know, it sounds crazy.
I'm looking at this number, and my instinct is that they are wildly oversimplifying. I mean, just 50 classes for 80% of an entire multi-billion-dollar mining operation. I pictured thousands of unique, specialized machines.
It sounds suspiciously low until you look at the principles of industrial engineering. Massive capital expenditure relies heavily on standardization.
Okay, that makes sense.
Yeah, a mine doesn't want thousands of unique machines because that means stocking thousands of unique spare parts and hiring wildly specialized mechanics. They buy fleets of the exact same haul trucks.
Oh, right, efficiency.
Exactly. They use identical pumps across different processing stages. So those 50 classes in Tier 1 carry the vast majority of the daily operational value.
And what about the rest?
Well, beyond that, you have Tier 2, which introduces about 300 types. These are the variants and subtypes, so the system can handle slight modifications. Finally, Tier 3 maps 1,000 to 2,000 maintainable items.
Like the smaller parts.
Yeah, exactly. These are the consumables, things like liners, bearings, seals, valves.
It really is just the 80-20 rule applied to physical reality. I mean, if you master the core 20% of the tools, you can handle 80% of the workday.
Exactly.
But here's the part that still feels like magic to me. The library isn't just an arbitrary list EON made up. The sources mention it is anchored to the ISO 14224 taxonomy and tailored to the mine's specific asset hierarchy under ISO 55000.
Yep. Very specific standards.
And for anyone outside of heavy industry, those are just compliance codes, right? So can you explain the translation layer there? Like, how does visual data of a dirty, broken pump in the real world actually get translated into an ISO 55000 standard database entry?
Yeah, that is the crucial bridge between physical chaos and corporate order.
Hmm.
So ISO 142224 is the de facto cross-industry equipment standard. It defines a universal hierarchy.
Okay, from the top down.
Exactly. From the entire plant down to the unit, down to the system, and finally down to a specific piece of equipment. When a worker wearing an AR headset looks at a pump, the AI's computer vision isn't just matching a picture and saying, hey, that's a pump.
It's doing more than just image recognition.
Way more. It recognizes that specific component as a structural node within the mine's digital nervous system. It identifies the geometry, cross-references it with the ISO standard, and immediately maps its output straight into the mine's existing maintenance databases.
Wow. So it speaks the exact data language of the mine from day one.
Precisely. You aren't forcing the mine's IT department to adapt to the new software. The software already speaks the mine's dialect.
So because it is this composable library speaking a universal data language, every time someone uses it or, a new configuration is encountered in the field, it makes the shared library smarter.
Right. The system is always learning.
It turns training from a sunk cost that constantly needs updating into an asset that actually compounds in value. But having a vocabulary of 50 machines is one thing. Recognizing a shovel and mapping it to a database is just object recognition.
Right.
I mean, my phone can recognize a dog, but my phone doesn't know how to feed the dog or diagnose why it's limping.
Good point.
So the AI has to actually comprehend what the machine does.
Yeah, identifying a machine is just a label. Understanding it is an entirely different technological leap. EON Universal defines what it actually means to, quote-unquote, know a component by breaking it down into 6 structured layers of competence.
Okay, let's dig into these 6 layers because this seems to be the actual brain of the operation.
It really is.
The sources list them as identity, geometry, anatomy, function, behavior, and procedure. But, just listing them doesn't really explain how they work. For example, what is the actual mechanical difference between geometry and anatomy?
Yeah, they sound similar.
Right. If an AI has a 3D scan of a machine, doesn't it automatically know its anatomy?
Not at all. Geometry is just surface pixels in 3-dimensional space. It is basically a mesh. A system with only geometry knows the shape of a box, but it thinks the box is just a solid block of pixels.
Ah, okay. It doesn't know what's inside.
Exactly. Anatomy is the understanding of physical boundaries, joints, and mechanics. A system that understands anatomy knows that a specific section of that mesh is a hinge, that it has a physical tolerance, and that it connects to a separate internal subcomponent.
Oh, I see.
Yeah, think of it like this. Geometry is knowing what a human body looks like from the outside. Anatomy is knowing where the skeleton and the organs actually are.
That makes perfect sense. So identity gives it a name, geometry gives it a physical shape, and anatomy maps the moving parts. What about function versus behavior? Because those also sound like synonyms.
Right, so function is the intended purpose of the machine. It is the manual. Like, what does this machine do when everything is going perfectly, and what is its safe operating envelope?
Okay, and a behavior.
Behavior is the physics of failure. It is how the machine responds to upsets.
Oh, wow.
Yeah, if a valve gets stuck or if the pressure drops, what are the cascading physical consequences? Behavior is understanding the physics of the machine when it is operating outside of its intended function.
And then the final layer, procedure, is the dynamic instruction set of how to operate it, inspect it, isolate it, and fix it.
Exactly.
Those 6 layers seem to represent the exact boundary between older technology and this new intelligence. Like in the source material, there is a very sharp distinction drawn between EON's older engine, which is called Genesis, and this new EON Universal system.
Yes, very sharp.
Genesis is essentially a simulator that runs sequential standard operating procedures, SOPs. It just shows the worker the steps on a screen. But EON Universal brings the actual intelligence. It knows why each step exists.
Matt Johansson, the president of EON AI Ventures, has a quote in the release that really just sums this up perfectly. He says, "Genesis shows the steps. EON Universal understands the work. That single sentence is the product."
It's the difference between blindly following instructions and actually possessing mastery.
Exactly.
It's kind of like Genesis is like a home cook following a recipe card. The card says fold the egg whites, and the cook does it, but they have no idea why. They just know it is step 4 on the list.
Right. They're just following along.
But EON Universal is like the master chef who understands that if you stir the egg whites instead of folding them, you knock all the trapped air out, you destroy the protein structure, and your souffle will collapse in the oven. The chef understands the fundamental physics of the food.
That is a perfect analogy. And we can see exactly how that mechanical understanding plays out in the real world with the proof example they provided.
Oh, the hydraulic excavator.
Yeah, isolating a hydraulic excavator for maintenance.
Okay, take us out into the dirt. Paint the picture. We are standing in an open pit mine, the dust is blowing, and we need to isolate a massive excavator to safely change out a part.
Okay, so if you are using a standard fixed procedure, like a straight line of text from an older system, the instructions might say, step 1, shut down the machine. Step 2, lock it out so nobody can turn the ignition.
Standard stuff.
Right. Step 3, lower the implements to the ground. Step 4, start unbolting the hydraulic panel.
Which sounds completely logical. The engine is off, the keys are put away, so it should be totally safe to open it up.
It sounds logical until you realize that standard text procedures cannot account for dynamic live conditions. Like, what if the machine experienced an emergency shutdown while the boom was still elevated?
Oh, I see.
Yeah. EON Universal knows, specifically because of its behavior layer, that a shovel's hydraulic accumulators can still hold immense, lethal pressure even long after the engine is completely off.
Verifying.
It also knows from its anatomy and behavior layers that if the boom is raised, it is storing massive amounts of gravitational energy. We're talking thousands of pounds of steel just waiting for a valve to release so it can fall.
Because gravity doesn't care if the engine is turned off.
Exactly. Genesis, the older system, has no concept of stored energy. It just knows the sequence of text on a page. But EON Universal understands the physics of gravity and pressure. Therefore, it creates what they call a conditional SOP with a safety gate.
I want to admit some confusion here, though. How does a software system actually halt a human being in the real world?
What do you mean?
Like, if I'm wearing AR glasses and I'm holding a wrench and I'm about to undo a pressurized bolt, how does the AI stop me? Does the wrench lock up? Does the headset flash red?
Okay. So it creates a procedural software gate. Before the worker is allowed to proceed to the unbolting phase, the system forces a mandatory branch in the decision tree on their interface. It asks a diagnostic question. Is stored hydraulic energy still present?
Oh, so the worker has to check.
Yes. The worker must physically verify and input the state of the machine. If the answer is yes, the procedure dynamically branches away from the standard path to guide the worker on how to safely bleed the accumulators step by step.
That is incredibly smart.
And it then forces a recheck. Only when the software receives confirmation that the stored energy is gone does it unlock the next step of the procedure, allowing the unbolting to commence.
And what if something goes wrong during that?
If anything is abnormal during that bleed process, the system escalates. It stops the job on a screen and requires a human supervisor to log in and verify the safety state.
Okay, so the AI truly understands the physics and the behavior of the machine rather than just reciting a script. It takes this training out of a sterile, perfectly predictable classroom and projects it into the chaotic, messy, real world where things go wrong.
Exactly.
But a worker cannot drag a supercomputer down a 3,000-foot mine shaft. How is this deep physical intelligence actually being delivered into the dirt?
This is where the delivery surfaces come into play. The beauty of modeling the vocabulary instead of mapping the entire geographic site is that you author the content once in the central library, and it can meet the worker wherever they happen to be on whatever hardware they have available.
Okay.
The sources outline three main delivery tiers. First, there's anywhere. This relies on just a standard smartphone or a pair of lightweight AR glasses. A worker sitting in their camp bunk or even in their living room back home before they fly out for their shift can project a one-to-one scale digital model of a component onto their floor and practice the teardown.
Oh, wow. With no physical hardware needed at all. And the second tier is on-site. This is where the integration feels incredibly futuristic to me. A worker takes an industrial tablet or wears AR glasses and walks up to the actual physical haul truck in the maintenance bay.
Yeah, this is where it gets really cool.
The system uses the device's LiDAR scanners to read the geometry of the physical machine, and it overlays a digital twin directly on top of the real steel. Suddenly, every physical part of that truck is tappable and interactive through the screen or the lenses.
It's basically X-ray vision.
Exactly. It reminds me of how modern surgeons use real-time MRI and CT overlays during complex procedures. The surgeon doesn't have to guess where the tumor is beneath the tissue because the digital overlay is painting a glowing target directly onto the patient's anatomy.
Right.
The mechanic is getting that exact same X-ray vision for heavy machinery.
And finally, there is the immersive tier. They call it the CEE, or the holodeck. Imagine a massive room where the walls and the floor are entirely comprised of high-resolution LED screens surrounding the trainee in a full-scale generated pit or processing plant.
That sounds intense.
It is a premium, completely immersive environment reserved for the most critical, high-stakes training scenarios where spatial awareness is paramount.
And because of the underlying intelligence driving these delivery surfaces, they unlock capabilities that scripted simulators simply cannot touch, right? You have features like talking components,
Yes.
where a worker can physically tap a part in AR and the part itself explains what it is, what its tolerances are, and how its internal mechanisms connect to the rest of the system. The machine is literally teaching you how it functions.
You also have fault injection. Instead of following a fixed script where everything goes perfectly, the AI can actively inject a live, randomized fault into the simulation.
To test them.
Exactly. A pressure valve suddenly drops in the digital twin. The trainee has to diagnose the problem on the fly, recognizing the abnormal behavior based on the machine's physics, and respond appropriately.
Which is how it would happen in the real world.
Yeah, and all of this leads to scored certification. It provides defensible, measured, objective evidence that a green worker is actually ready to touch the real equipment, measured against an exact standard rather than just, trusting that they paid attention in a classroom.
Here is the massive implication of all of this, though. This technology is not just for mining. Because this entire system relies on that bounded part vocabulary, the composition model we talked about, it transfers to literally any heavy industry on Earth.
That's the real game changer.
The sources mention that oil and gas is already their first active build, and they are quickly following up with aerospace maintenance and power and energy grids. It is all the exact same fundamental principle. Teach the AI the vocabulary of the parts once, and you can instantly help every single site on the planet built from those parts.
Which brings us to the ultimate structural shift in how these global industries are going to operate.
Right. When you zoom out from the AR glasses and the hydraulic accumulators, what is the actual business impact of this shift? What is the end goal here?
EON AI Ventures defines their ultimate goal as creating something called work intelligence. Think about how a modern global corporation operates today. If a company wants to track its physical resources, its supply chains, and its payroll, it uses an ERP system.
Right.
If it wants to track its relationships with thousands of customers, it uses a CRM system.
They use enterprise systems of record to centralize messy information.
Exactly. Work intelligence aims to be the enterprise system of record for how physical work is actually done in reality. It fundamentally shifts how we view, store, and transfer corporate knowledge. You are no longer relying on the gray matter inside a 30-year veteran's head, just hoping they bother to write down their hard-won judgment before they retire.
Because once they're gone, it's gone.
Right. Instead, the knowledge of how to fix the machine becomes a digital asset that the enterprise actually owns, and one that compounds in accuracy with every single shift worked across the globe.
There is a quote from Dan Lajerskar, he's the founder and chairman of EON AI Ventures, that really highlights the magnitude of this gap in the market. He pointed out something crucial about the limits of the AI we interact with every day.
Oh, about the internet data.
Yeah. He said that general-purpose AI, the massive language models, writing emails and generating code, can learn everything that exists on the public internet, but they cannot learn how your specific underground mine actually runs because that knowledge has never left your sites.
It's nowhere online.
It is not on Wikipedia. It
No.
isn't in a digitized textbook. It is dark data. It is trapped in the dirt, in the noise, and in the hands of the workers. And EON Universal is the bridge to capture that unwritten physical expertise and digitize it.
It acts as the ultimate safety net for a workforce that is undergoing a massive, chaotic demographic transition.
So why should you care about this? Whether you are managing a massive team navigating knowledge loss, or maybe you're tracking the absolute bleeding edge of artificial intelligence capabilities, or you are just fascinated by the psychology of how mastery is transferred from one generation to the next, this represents a tectonic shift.
It absolutely does.
We are moving from a long, painful era where fragile human beings had to meticulously memorize the quirks of massive machines to an era where the machines are finally memorizing the intricacies of the work, specifically to guide the humans safely through it.
The AI does the understanding, so the human can do the doing.
But mapping that dynamic leaves us with a lingering, almost philosophical puzzle. Think back to that massive, terrifying machine from the beginning of our deep dive. You walk up to it, and the AI in your glasses maps the geometry, deeply understands its physical anatomy, calculates the behavioral physics, and dynamically guides your hands through every single step of the labor, locking you out if you make a mistake. If an AI system can do all of that flawlessly, well, how long until the human worker essentially just becomes the biological, physical avatar for an AI's brain? The hands to the machine's mind?
That's a wild thought.
And in a world where you never have to memorize a physical procedure again, where the glasses always highlight exactly where the dangerous stored energy is hidden, what happens to the human instinct for intuition?
Yeah.
What happens to our innate ability to troubleshoot, to just feel when a machine is running hot, and our true physical mastery over the world when the machine is doing all the understanding for us? Something to think about the next time you follow a GPS blindly for an hour, only to realize you have absolutely no idea how to get back home on your own.